common criteria certification and especially how it relates to open source projects. So this is the short agenda. First, like common criteria, what it is and why you use it, and then how it relates to open source, how it works together with open source, and how can an open source project be common criteria certified, and how does the certification affect the project. And you can interrupt with questions at any time, just feel free. So first, how many of you think you have some hunch of what common criteria is all about? Everyone, almost. Fantastic. Let's see if it's really like that. So, what is common criteria? Well, it's short for Common Criteria for Information Technology Security Evaluation. And it's a standard for computer software certification defined by ISO, etc. blah blah blah. And what does it provide? It provides assurance that the specification, implementation, and evaluation processes of certified products are done according to a rigorous and standard way. And there are certain ways why you want to have this, which we will come back more to later. So, who uses common criteria and why? Well, there are three kind of user categories which are interested by common criteria. One is, of course, computer system consumers, the actual customers of a product, and they want to specify their functional and security requirements and assurance requirements. Then there are the vendors, of course, who can advertise that their products are certified to get into some deals, etc., and sell better. And then finally there are testing laboratories who make a hefty amount of income by actually testing and evaluating different products. So those are the kind of three categories that are interested in common criteria certification. So why on earth would you want to go through a common criteria certification? Well, basically the only reason why you want to do it as a developer or vendor is that user groups like banks, governments, and major corporations sometimes require certified software in order for you to install them in their system or in order for them to use it. And of course, open source vendors like ourselves have the same requirements as proprietary vendors. So either you're in or out if you want to make business or if someone wants to use your software. It's very binary. So one thing that is kind of put forward here immediately is that common criteria is very static certification. We'll get back to that more later. So we have one certified version, and that means that no other versions are certified. So now we have established that yes, if you have some users who actually require common criteria certification, then you as a developer, you want to do it. So how does it work? And what do you do? So there are four, four different actors in a common criteria certification. One is the sponsor, who actually pays for it. One is the developer, who implements the software. The third is the lab, who does the evaluation. And the final one is the certification body, who actually issues the certificate. That means they sign the nice paper that says that this software is common criteria certified. So those are the four actors in a certification. And what does the certification do? Well, it tests a few things. Primarily, it tests documentation.
Security.
Spelling error, exactly. The common criteria evaluation tests that the documentation of security functions is complete. That you don't, leave some stuff out or make a half-assed job of documenting your things. And secondly, it also tests the implementation, that the security functions actually do what you claim that they do, which is probably the most interesting thing. And they also test things about the development environment and development process. So they test that the development environment is fairly secure and that you have somewhat secure development processes. So it's not trivial for someone to break into your system and plant malware into the software, even future versions, because nobody wants that. So that's the basic things that the common criteria certification tests. And now, to spin your heads, we will say that common criteria, this is Mike's words, it's just a very large amount of three-letter acronyms. So this is the first thing when you do a common criteria certification, you have to figure out what the hell does all this mean. And there are all these three-letter acronyms and they reference to each other, and it's just very hard to remember what the hell is a TSF or IMP, etc. And when you go through the evaluation, you get a message from the lab that says, well, you failed to document ARC_FLC1 in the FSP. And you say, what the hell does that mean? So you have to Google to see, okay, what's the FSP? Ah, that was that.
Do you know the meaning of all these which you have written?
Almost.
Like TSFI?
Yes.
Is
Trusted Security Function. No, TOW Security Function Interface. Exactly. And it's kind of recursive acronyms as well, because TOW is another acronym. So this is a TOW Security Functional Interface. So this acronyms in acronyms.
Part of the evaluation security.
So the first thing is when you start with the certification, it takes some time for actually to get to learn all the terms, at least to a level where you can do something about it. So that's like the first 6 months of the evaluation period.
Well, not just terms, right? There are also like specific concepts you have to get around your head around.
Yeah.
And it's not terms, it's an extra layer.
Exactly. Well, if you learn what the TSFI means, you actually it doesn't say much. You also have to understand what concept is and how it links together.
EAMS levels, I guess.
Yeah, evaluation assurance level. So we will go through these a little bit more to get your head around it. So when you start with the common criteria certification, you have a few documents to start with. The first one, of course, are the common criteria standard. They are actually freely downloadable, unless many other ISO standards. But that's, like 4 or 5 documents, 200 pages each. So that defines all the predefined requirements, because there are a lot of predefined requirements which you can choose from. So I would say that's primarily targeted at the evaluators. The evaluating lab is the only one who actually can read and understand the standard documents. Secondly, you have a protection profile, if you're lucky, that is, which we were. And that is predefined requirements for a certain type of software, for example, firewalls, smart cards, certification authorities. And those are documents that are created by user groups or governments. For example, NIST, Department of Defense, or EU creates these predefined security requirements, which just says that a certification authority must be able to issue certificates, must be able to manage replication information. And the same with smart cards, it has to create digital signatures, etc. So with the basis of only this, you start a certification process. And then you have to start to create a lot of things. So this is what we have to create as the developer. Well, as you see, this is only page 1 of the list of what you have to create. First, you have to create the security target. The security target describes all the security functions that your software has and the threats that these security functions are meant to counter. I mean, there's no point in having a security function if it doesn't correspond to some threat that you want to counter. So, luckily, if you have a protection profile, this is actually mostly a copy of the protection profile. So, this one, you're lucky. Then comes the stuff that you have to create from scratch. First, we have a functional specification, which describes all the security functions in detail. I will show you examples of it. Secondly, we have a design specification, which describes modules and interactions between different modules in your software. And then we also have implementation representation. Here we are also lucky, because this implementation representation is basically a list of all the files in your software. And they are kind of nice. We can use a tool like Doxygen just how to generate this. So that's probably the easiest of them all to create. Page 2 in the long list of documents that you have to create is something called a preparative procedures. That's how to configure the system in order to be a certified installation. Yeah. Then we have operational user guidance, how to use the system. We have a test plan, which where you have to document tests and actually test protocols for all the security functions in your system, so you can prove that you have tested everything. We have a security architecture that defines how your software implements security in a kind of architectural way. Something called Lifecycle support, which is probably the document that affects your open source project the most. So we'll talk a lot about this. That defines the processes for development and release, and how you, for example, accept flaws, issue reports from users if the user finds a security problem, how you receive it and handle that. And also configuration lists of all files and external dependencies if you use other libraries like Apache libraries, etc. You have to document these as well. So that was only 2 pages of different documents that you have to create during the evaluation period. So I will show you a little bit more in detail about what these documents are, and describe some of these 3-level acronyms. First, then the security target, as we mentioned. The security target defines the TOE, which is the target evaluation, your software. And it describes the TSF, which is the TOE security functions, the security functions that your software implements. One of the most important things that the security target defines is actually the boundaries of your target of evaluation. It defines what is inside and what is outside of the evaluation. That means what the lab will actually look at. So this is, in our case, in the cesecore project, we determined that the actual software, the Java files that we developed, and the configuration of those, that is what is inside the target of evaluation, what is actually evaluated. Then outside we leave like hardware security modules, database, and applications that use this API. That is out of the scope of the evaluation. That means that the lab will not, if we use MySQL or Postgres, it means that the lab will not bother about the security, or mostly not about the security of MySQL or Postgres itself. So they will not, look into the security features of the database. So it can be how insecure as you want, basically. What do you have to take care of is actually the connections to these. So then the lab focuses on this gray part. That's very important to define what is inside and outside of the scope.
Did that require negotiation, or they don't said that we would like to have the whole package evaluated, or you define it, or?
It requires a little bit of negotiation. For example, like the DB, you have to say, well, can we say that the database is completely outside of the scope? Well, yes, you can, but actually the data that is stored in the database, that's more or less part of the application. So even if the database is outside of the scope, the data itself in the database must be integrity protected. So even if the database itself is insecure, then the data itself is secure that you put into it. So, and then you have to ask the lab, is that okay to, don't care about anything about what's stored there? No, they will say no, you have to have some integrity protection, etc. So you can negotiate a little bit. You can probably negotiate to have configuration outside or inside, etc. So you want to try to make it as easy as possible for you, but still provide fulfilling the requirements and having a decently secure product. The next, function specification. There you have to, well, you're not supposed to be able to read all this because I can't even read it myself. But it's, you have to actually define all the modules in your software and the interactions between them. So you have to put all your modules here, and then you have to figure out which module calls what, etc. So it can get pretty complicated. And that's only the first step of the functional specification. The second step is that you have to get into more detail. You have to define all the, you have modules, and you have what are they called? Functions, and well, there are three things, and they are named differently in different documents. So I will get back to that also slightly later. So you have to define in very kind of detail. You have, for instance, certificate and profile management, typical component of a CA. And there you have to define that you have certificate profiles, so you have CRL profiles, and you have CRL issuance, and certificate issuance. And you also have to define all the individual functions. So it gets fairly hairy with details. So this is just one example of a one thing that is required in the protection profile that we use is a backup and restore. And then you have to describe very much in detail, this is the restore function. So you have to say, what's the purpose of the restore function? Well, to restore a backup, of course. How do you use it? What inputs do you have? Well, the previously made backup is the input to restore, of course. What actions does the restore function do? What's the output? Well, it's a restore TOE. And what error messages, what security event, the log events happens, etc. And finally, you also have to define in the security target what is called the SFR, security functional requirements. So you have to link this function to what security requirements does it fulfill. So then everything can be backtraced back and forth to see that, well, we have these requirements, and that requirement is implemented by the restore function, and the restore function implements these requirements. And finally, you also have to say which interfaces this is available from. And this has some later on, when you actually test stuff, if you have a lot of interfaces, you can have, like, if this is command line interface, you can also have web interface, web service interface. Then you have to make tests for all these interfaces that you define that the function is available to. We have design specification later on, which in some way describes the same things, but in a different way. So you have still the backup and recovery. You describe, well, what does backup and recovery do again? And then you have to say which interactions it has with other modules. So, well, to make a backup, we have access control to see that you are authorized to make a backup. We have key management for encryption and signature keys for the backup. And finally, it has interaction with the security audit module to actually make to log that we did perform a backup. And you have to describe all these interconnections in detail. And the most confusing thing, one of the most confusing things, I think, is that you have you need complete mappings between all these documents. So if you describe something in the function specification, corresponding things has to be described in the design specification, and it has to match something in the implementation as well. So if something is missing, you describe something here, and you don't have the same thing there, the lab will complain, etc. Or if you describe something there and you don't have a something implementing it, of course they will complain. And to make it more confusing, they actually call things differently in different documents. So in the functional specification you have something called a functional module, but in the design specification it's called a subsystem, and in the implementation, well, we use Java, so it corresponds to a Java package. In the function specification you have an interface, but in the design specification it's called a module, but in the function specification this one was called a module. So you get a bit confused when you work with this and you start, well, a module, that was a module. No, it's not a module, that was an interface, that's a module. And now that's an interface over there. So that's a cause of a lot of headache. So, before I started with common criteria, I surely had a lot of prejudice about common criteria, and I'm sure many of you have a lot of prejudices about common criteria, especially if you haven't actually gone through one yourself. So, how many have gone through one yourself? That's
Still going through it.
yeah, that's the best crowd so far, I think. Well, some prejudices. Well, it's expensive. It's a waste of time. It's just paperwork. It doesn't, do any technical stuff. Certified products are only old versions. You can easily get that feeling. And why should certified products actually be better? Well, there are some prejudices. Some of them I had, and some of them I still have, and some of them I have actually converted into other prejudices. So, the truth, well, my truth about common criteria, it does take a lot of time. So that's the prejudice was certainly true, and it does cost a very hell of a lot of money. But it's not only paper, it's really technical evaluation. Depends, of course, a little bit on which evaluation level you're going to, but the one we did, 4+, is quite technical. It's true that certified versions are old. We'll get back to that a little bit. So, you never have the latest version is never the one that is the common criteria certified version. It does provide actually product improvements if you do it kind of properly, and it will improve security in your product during evaluation, unless you had an extremely good process even already before, which I would say is rare.
One of the things most striking is that common criteria thinks of itself as a methodology you should apply before even starting to write your product. But almost everybody uses it after the fact. Everything has been designed, everything, so you're retro-documenting and adding and really rounding the corners that you...
I think that's a question for the end, but so in open source we apply it often after the fact. In all industries it's applied during design.
No, all the industries usually...
Business comes first, process comes later, usually. That's the truth.
I can think of a few industry products where this was done from inception, and in those cases the cost is almost negligible, the extra cost is almost negligible. So one of the questions is whether in the open source world something like that can be done as well.
Well, if you're thinking about smart industry, the first versions they were doing it after the fact. And after the...
I'm thinking of like satellite control systems. That's my background.
That's the second generation of evaluated products. I'm thinking about CAs and everything that's about signature. That's done after the fact.
Yeah, that's the horrible work we have, right? DPI, CAs.
Well, I think probably either case, even if you do it before, well, if you do it with inception, your development of the first version will be a hell of a lot more expensive than if you didn't do it before. So it still costs a lot of money and takes a lot of time. Your development is slower from start, etc. But of course, other common prejudices, but from a user perspective, that means the governments or that actually requires this, is that such a certification should guarantee secure software. Well, it does not, of course. says certification is not worth anything, can also be a prejudice. Well, it is. So probably somewhere in between here. It's worth something, but it definitely doesn't guarantee that's secure software. That's because the CC actually assures with a certain level of assurance, which is this EAL level, that the product works as documented that it shall work. And the keyword here is documented. So if you document that your product doesn't do something, or if you don't document that it does something, well, it doesn't care. The evaluation doesn't care what your software doesn't do. It only cares what you say it does. So that's why protection profiles and security targets are important, because they are the predefined security requirements. And the key with that is that actually these protection profiles and security targets, that's I would say one issue with common criteria, that in this standard it's supposed that actually the user should be able to read a protection profile for a security target and make some kind of judgment. Is this product evaluated to what I want, or have they just evaluated the functions that I'm not interested in? But of course, these documents are way too complex for any normal user, even if it's a government, I would say, to read today. So in practice, it's not possible. They just check, oh, it's EAL 4+, so it must be good. And from that also follows that different vendors of different products, like HSMs, they can claim that, well, our product has certified all of this, but our competitors' products only certified a small part, because everyone just looks at this, and it's too hard to actually read and understand what it says in the security target. For the developer, it's very hard and cumbersome to keep track of all the details and mappings in these documents. And actually, this long list of documents, you only, as a developer, you definitely only do that if you get paid for it. No one would ever dream about doing this otherwise. So that's why most commonly I would say these documents are at least to a large part written by consultants, because it's too boring, cumbersome, difficult actually to get it right. The certification can both prevent some refactorings. If you have something certified, you don't want to change it a lot. But on the other hand, if you're doing certification and you think, well, we should do this right, then it actually will encourage refactoring to make it so you get the right certified version.
Could you imagine in your product doing very significant refactoring or rewriting of parts of the code as to generate a much larger part of the documentation, or generate in such a way that it actually can really be reusable under the line of fixes and things like that?
Can you repeat?
So could you imagine that in taking your core, you either rewrite it or refactor it in such a way that a very large part of documentation either gets generated from it or becomes completely static effectively? So you try not to write it, so you basically try to tune the code to this process as much as possible.
That's possible to some extent, I would say, but you can't really generate these documents from the code, unfortunately, I would say.
Can I interrupt?
Yeah.
I think for this project, in a way, we have tried to do so, in the sense that we did the project first called Common Criteria, which is an API for our CA and then some other products as well. And it turns out that even in creating an API, I think everyone would agree with me, is very, very difficult. And then if you are successful, I think you get where you want to be. But I think being successful in this is very difficult.
So the reason I ask in some non-internet industries, this is recognized as a big problem, and very often you see the software modules which have to be certified be written in very awkward, very primitive ways. which effectively means that this whole process becomes organizationally and for the developer very, very simple and cheap. Sort of like very non-error prone effectively and has very little maintenance. So one of the things I've been wondering about also watching OpenSSL struggle is whether around some of the security products, the core of open source, we need to take a step back, simplify them massively, move the APIs massively in so that some of this can be done in a much more static way. Just the same way that, for example, the Apache Software Foundation, initially we had to struggle with how you dealt with the liability issues around code contribution and to bring back these contributors agreements and CCAs and CLAs and all sorts of that legal documents. That was a very similar process.
Actually, it's kind of what we did. So I will actually show some architecture of that just in like 2 slides. So we'll get back to that definitely. Well, just finally, that during certification, it's as for a developer perspective, it's not just something that you have to overcome. You actually do get from the certification lab very good input and testing. The certification lab really are there to help you. They are not interested in stopping you from getting certification. They are, of course, interested in your product getting certified. Well, they get paid for it, and they're usually nice guys, so they will help you to interpret the requirements in a good way for you, etc. And actually test your product very nicely. So, how much does it cost? Is a common question. Well, for us, it took like 2 years, where we had at least 3 to 4 people full-time during 1 year, full year. And just the testing lab costs more than 50,000 euro. So it's a very expensive process. So we spent at least a couple of €100,000 doing this evaluation. So it's not for the weak-hearted, I would say. So to be more very specific for open source, if open source kind of discriminated by common criteria because it's so kind of tuned for other proprietary software? Both yes and no. The same requirements are for open source and proprietary software. Common criteria doesn't care if your source code is open or closed. It's not secured by obscurity in any way. There's no requirement that you can't fulfill in open source software. On the other hand, yes, because it requires strict control over repository and committers. So that's definitely not the perfect match for a community-driven project, where you don't know everyone. There's no single entity that knows all committers and where you have resource for repository, etc. The lifecycle requirements requires very tight control over how you handle issues, etc. So it kind of enforces a slightly centralized development model. And of course, it's very high cost, so it requires actually some company which has enough money to be able to pay for certification. And all this, I would say, particularly high cost, leads to that there's virtually very few publicly downloadable common criteria certified open source software.
If you would use like Git or something, where you have where the committed to pull patches from others, how would that work with a strict control? Would the people you pull from would have to be like sign agreements and so on, or
yeah, I guess the entity who actually assembles the final software, which holds the official certified version, has to have control of what it pulls and from where. So this there's someone who pulls into the kind of official release version, and so you have to have control over those people.
Which other?
Like the Apache Open Source Foundation have exactly the same problem as liability. So we have exactly this problem, and that is basically why there are all sorts of legal documents around Apache Git or SVH networks, which basically make the foundation legally having sufficient oversight over the code base. You know that when something ships from that repository and release build, that is the organizational oversight and building that version of that capital effort. that's the same thing. It's a process.
There's no requirement, there's no technical requirement against open source, but there are prejudices in all the human parts of the process. And so the lab is usually not a problem, but it doesn't know much about open source software. And sometimes the evaluator is a bit prejudiced against.
Yeah,
so
that can be.
So there is no technical, but you have to still do some kind of evaluation of the different human parts of
Yeah, you have to select the lab carefully then, of course. We, had, how do you say, procurement for the certification where we had 3 different labs put in their offers, and we choose a French lab which had worked with open source before, so they know what it is and are not prejudiced.
You seem to know that. Can you name some other open source things that are common criteria?
Yeah, I'll in 2 slides.
Okay.
So the other thing that is kind of open source about common criteria is that common criteria process is, I would say, like an extreme waterfall process. You document first and you implement later, and you have to have everything super documented. That's not kind of so agile as most open source projects work today. So you can kind of see that the common criteria process was invented, some years ago, I would say. So CC common criteria definitely not created, with fast development and flexibility in mind. It's rather the other way around. It's very static, extremely static. Once you have a certified version in a specific environment, which means a specific version of operating system, a specific version of application server, hardware security module with a specific firmware version, that is the certified version.
That's not a requirement of common criteria. That's just because you have to do the evaluation and you have to do the testing on all those platforms, so you usually limit yourself to one platform.
Yeah, 2 in our case, but I think that's also, you have this static one, but of course you have, security patches for all operating system, even for hardware security modules. But then when you apply the security patch to the operating system, that's no longer the certified version. But that's some other things, how it's supposed to be used or not. Well, you can do some things to remedy this. There's something called impact assessment. If you do fix a patch, you make an impact assessment to say, well, this doesn't affect any of the security functions, and then the users are supposed to read this and say, well, of course it's better to use this new uncertified version than the old certified, because the actually certified version has security bugs. This newer version doesn't. And of course you can do recertification, which is yet a new process, but still, if you have all the documents kind of in shape, and then of course that's a lot cheaper at least. This leads to that there are very few open source products which are certified, only from larger companies. Red Hat, Enterprise Linux, JBoss, of course the enterprise version is certified. IBM surely has certified versions. I put Frankie there. We're not a large company, but I think it looks funny. And of course, there are even fewer that are publicly available. Even Red Hat has certified that, but Red Hat Enterprise Linux is not publicly downloadable, although it's open source. And unfortunately, it's going to be the same with our software. It's just too expensive. So that's also one. That's probably the biggest thing that is kind of against open source in common criteria. It's so expensive. But on the other hand, there are probably lots of proprietary products that are built on open source which are certified. If you get like a certified product from IBM, which is not open source, I bet you it's based on Apache, for instance. So in that way, Apache is certainly certified, but you can't go to apache.org and get the certified HTTP server. So this is what we did, which kind of relates back to Dirk's questions before. We kind of did things actually in a shifted way a little bit. First we had this EGBCA product, and what we did is we took the security functions from the Java code, and we broke it out into a separate completely new library, the Java Enterprise Component Library, and refactored to fit as good as we could make it, and with software and the modules which kind of reflects the security requirements, etc. And then we certified first this component library. And then the second step is that we took this newly certified component library and we refactored it into EDBCA again to make EDBCA certified. So first we certified the component library, and then we put it into EDBCA and we certified EDBCA. That is, they call it a composite evaluation, where you have actually one certified something certified inside another product, which makes it a little easier to certify this product because it already has the core certified. So in that way, we actually tune this one to hopefully be a little bit more static than this whole software, so that the certification parts or the certified parts would change less and be easier to recertify, etc. That's the whole point.
Has this improved things, or has this made things architecturally messier?
Improved, definitely.
And is this an endpoint, or do you see this go even further, better?
It always goes further better, definitely. So there are a lot of things that we want to improve already, but once you change something, it's not certified anymore. But that's something else. There's some more. What we did, EL4+, we had luckily there's a protection profile for certificate authorities, so we could use that. It's called a CIMC. There's a common criteria version where this protection profile was actually written by NIST some years ago, and it was written for an older version of common criteria, version 2.1. When you certify something today, it's common criteria version 3.1, so you have to change some things to adapt it to the new common criteria version. So that's also, even the protection profiles are a bit, too static. It's valid for like 2 years, and unless NIST feels like they want to spend a lot of time and money to update the protection profile, you have to do it yourself. What is different in open source compared to proprietary software? One thing is that we have a public repository, code repository. In proprietary software companies, usually have strict control over development machines. They know where from all developers are, and who develops. They have some legal control over developers because they are employed by the company. So, what can we do as an open source project? Well, to claim to have control over development machines, we have a user responsibility policy that all committers must sign. It's nothing special. It just says basically that yes, I have some malware protection, some firewall, etc. So the committer has to say that yes, I have some best effort control that my machine is not infected by malware, basically stuff like that. Where development is done from, actually that doesn't matter, as long as you have some authentication and encryption. So HTTPS and authentication is good. You can see it wherever in the world you want to commit. The same is with this legal control over who develops. That's this. You have to have some contract or this user responsibility policy. That's what we have. So what affects our project the most is this ALC, Lifecycle, the Lifecycle in the common criteria requirements. It actually requires that you have controlled access to the source code repository, which means both logically and physically. We previously had our repository on SourceForge, no more, because there's no way the certification lab can go to SourceForge and evaluate their hosting facility. So we had to move to our own hosting. So the lab could actually come and visit our server room to see that, well, there are badges with codes and loft tracks and things like that, fire protection. You also need a lot of processes for issue management, code review, testing, release management, not the least, because it has to be, release management is very important because the certified release has to be kind of authenticated, or the person who uses a release must be able to authenticate that it's a certified release. And so what we had to do, I told you about this user responsibility policy. All staff and external committer had to sign a user responsibility policy. We have to have access lists who has access to our repository, both logically and physically. For external committers, we use the same user responsibility policy, and we have a review process, code review. Otherwise, we weren't affected too much actually, because we had fairly good processes already, thanks to Tom there. We had Jira for issue management, fisheye code, the inspection, Hudson, continuous integration, etc. So we didn't have to change our processes a lot. The most thing we had to change the repository and introduce is access lists. So there's more administration, which takes more time. And we have to do a little more QA than before for each issue, which means that there's slightly slower development than before. You can't be as fast as when you're not certified, I would say. On the other hand, you get a little better quality assurance per issue. So actually you do get slightly better, I would say. For our sake, our software is better, better structured, hopefully slightly more secure, slightly better tested. So the code has definitely gained from our certification, but it has taken a lot of time and cost a lot of money, which forced us to change some things which maybe we definitely would not have changed otherwise. That's it.
Do you have like some specific things in the code base you can point out that were the result of feedback from the lab or something like that?
Yes. We thought that we did not have any SQL injection vulnerabilities because we had definitely checked that many times. But they found some actually, but that's what on the API level, so I don't think we didn't actually have it from the web interface, but we had it in the API level. So now even on the API level, it's doesn't have any, not any that we know of for the lab. That's one thing.
But I mean, like additions in components or changes.
Well, there are some funny components, especially in the API, which we put in the cesecore part. We had to put in this API here we have like a function for backup and recovery, because you have to have that, and this doesn't have a command interface or anything. So we have a Java API components for backup and recovery, which kind of sucks. So, but we must have those functions. So Mike had to implement those in some functions just to be able to fulfill all requirements and pass all the tests. But down here, we won't use those. So that's kind of a sham functions just to pass this component library through certification. And we don't use them down here. Here we instead use a command line interface to do basically the same. So there are
we've added some stuff for audit logs as well, and some other things, which I find very, very useful. But we probably would have done anyway.
Yeah, that's what kind of some sham bad functions which we had to introduce. The other, probably the best thing, as Tom said, is that the security audit now is awesome. And it's well specified exactly what is security audit. There's integrity protected security audit with digital signature or HMAC, and it's all the whole code has gone through very meticulously to ensure that the security audit is exactly as specified, and exactly as all requirements, etc. So that's that has been a lot better than before.
So a lot of this you go through to certify, and that's really sort of like to kind of like pass blame, to say like, oh well, it wasn't my fault, I certified, sort of thing, right? So what you sometimes see is that functions end up sort of like not being made stronger, but or security-wise, technically-wise made stronger, but sort of like make it much easier to sort of like figure out who was to blame afterwards, even if it increases the risk of that function going wrong. And it's very common, especially like in chip cards and things like that, where whole sort of engineering are made that way. Did you find you had to do the same thing in here as well, or was that relatively rare, or not at all?
I would say not, actually. So it's the only kind of sound engineering.
So you didn't end up sort of like a certain function that you had to add, which basically exposed all the issues.
No.
Which HSMs did you target?
SafeNet, Luna, and Utomaco. And yeah, we certified on 2 platforms. One was Red Hat Enterprise, JBoss, and PostgreSQL with SafeNet, Luna, HSM. The other one, don't know X around, Windows Server, MySQL though, and Utomaco crypto server, and Glassfish application server.
And from the cesecore website, at least, there should be like this is EGBCA, right? Centric talk, but what are the other applications to be built around the core?
Yeah, so we have this project was actually a cooperation then in order to get 50% funding from the EU, which we got for this. We had just us, a Norwegian company, a Portuguese company, and a Turkish company. So we have built this around it. The Portuguese has a timestamp server built on top of it, and the others have a time.
Okay. So with the CA profiles of NIST running out in a year and a half, 2 years from now, is there any chance that, like through one of the EU projects or through the EU folks in Greece, that can be rekindled?
With the protection profile?
Yeah.
Not that I've heard of, probably not.
It's not that you've heard of.
No. So, but then, I mean, the protection profile is actually outdated and not valid anymore, but that's also a negotiation between the lab and the certification authority, the certification body, that they, agree that, well, if we do these changes to this old protection profile, we can still claim compliance.
Where did you get, which certification body did you use?
ANSSI in France, and the lab was called OPIDA, French certification evaluation lab. Quite good in my experience. So we're very happy with that part at least. That we have nice people to work with. Okay. Thank you.